This is our second problem for mass to mole conversion. In the reaction CH4 plus O2 yields CO2 plus H2O, how many moles of CO2 is produced from 32 grams of CH4? So this is a combustion reaction where methane reacted with oxygen to form carbon dioxide and water. One of the requirements in stoichiometry is that you have a balanced chemical equation. And if you notice, this equation is not yet balanced. Therefore, we need to balance the equation first. Alright? So, we start balancing by accounting first all the elements in the reactant and product side of the equation, because we have to make sure that the atoms in each part of the equation of each element should be equal in both sides. So let's have carbon first. In the reactant side, we have one carbon atom. In the product side, we have one carbon atom. How about hydrogen? We have 4 atoms in the reactant side, and we have 2 atoms of hydrogen in the product side. How about oxygen? In the product side, we have 2 and 1. How about in the reactant side? We have 2. Alright, we can start balancing. Carbon, we will not balance that anymore because we have 1 each already. How about hydrogen? Alright, so to balance this, we have to multiply this by 2. Therefore, we need to put a coefficient of 2 beside H2O. So now we have 2 times 2, so we have 4 atoms of hydrogen in the product side. However, since H2O is a compound of hydrogen and oxygen, oxygen is also affected by the coefficient of 2 here. So there will be an adjustment. So this is also multiplied by 2. So now we have 2 times 2 plus 2 oxygen atoms in the product side. So we have a total of 4 oxygen atoms in the product side. So to balance that, we multiply this by 2. Therefore, we put a coefficient of 2 in the oxygen in your reactant side. So we have a balanced equation already. So this means that 1 mole of CH4 reacted with 2 moles of oxygen to form 1 mole of carbon dioxide and 2 moles of water. So we're ready to perform stoichiometry because we have a balanced equation already. So let's start with the given, which is 32 grams of CH4. Now, you cannot use the mole ratio yet because your unit is not in moles. So you have to look for a quantity that will relate mass and mole. What is that? That is your formula weight. So meaning you have to get the formula weight of CH4. So let's get the formula weight of CH4. So for the formula weight of CH4, you have to account the atoms. So for carbon, you have 1. For hydrogen, you have 4. And you have to look for the atomic weight of carbon and hydrogen from the periodic table. From your periodic table, the atomic weight of carbon is 12 and the atomic weight of hydrogen is 1. So just multiply. So this is 12, this is 4. Then you get the sum, 16. So 12 plus 4 is 16. So meaning, the formula weight of CH4 is 16 grams per mole. Now, you're ready to make this as your conversion factor here. But my question is, where will you put 16 grams and where will you put 1 mole? That's correct. You have to put 16 grams CH4 in the denominator and you have to put 1 mole CH4 in the numerator. Why is that? Because by dimensional analysis, gram CH4 cancel. You are left with the unit mole CH4. Since our unit is already mole CH4, we can now use our mole ratio. So what is our mole ratio? Since our given is CH4 and our required is CO2, you have to get the mole ratio between CO2 and CH4. From our equation, we can see that 1 mole of CH4 will produce 1 mole of CO2. So that is our mole ratio. For every 1 mole of CO2 produced, 1 mole of CH4 is needed. So this is just like multiplying by 1. So you perform the operation. 32 divided by 16 is 2. But this is not our final answer because we have to express our final answer in correct number of significant figures. So that would be 3SF because our given has 3SF. So you express your final answer in 3SF also. So this is our final answer. Alright? So meaning 32 grams of CH4 will produce 2 moles of CO2. So that is your mass to mole conversion.